All right, so here is the quiz y'all just took in class on Wednesday. Nobody missed number one. I haven't graded everything yet. Nobody in first period has missed number one. Let me state that. So what is it asking? Well, an ln has an understood base of e, so it's asking what power of e is equal to 22. So if I actually want to know the answer to that, and I think it's around 3, just off the top of my head, I'm just going to push ln of 22. So it's 3.0910. 3.0910. 3.0910. I tell you to go fourth decimal place, that means you include the 0. What is the domain of f of x equals this thing? You have a rule that says for a logarithm of argument a, which means anything on an interior is greater than 0. And this one hasn't gone too bad, but 4x minus 8 must be greater than 0. Add 8 to both sides. 4x is greater than 8. Divide by 4x is greater than 2. And if I like set builder, it looks like this. If I'm a fan of interval notation, it's 2 to infinity. 3 is where it started getting pretty rough in first period. We just don't seem to like to isolate. I don't know what to tell you about that. We're going to subtract 2 and get a 9. We're going to divide both sides by 3. So e to the 5x minus 2 is a 3. This is my base. This is my exponent, and this will be my answer. And the answer will become the argument. So we have a logarithm whose base is e, whose argument is 3, and equals 5x minus 2. And I saw a lot of kids in first period stop here. I'm going to rewrite log base e as ln. And then we're just going to do simple algebra. We're going to write the equation down correctly. We're going to add 2 to both sides. And then we're going to divide 3 by 5. And that's my answer. It's all over that 5. If I want to know what it is as a decimal, then I push buttons in a calculator. I'm not too concerned about the decimal. All right, what is the inverse of this function? First thing we're going to do is we're going to swap x and y. And I saw a lot of kids in first period divide the 10 out. 10 is a base, is it not? It is a base. Well, a little too early to talk about it as a base, but it is. Easy stuff first, subtract 3. X minus 3 equals 10 to the y minus 1. And I saw a kid tell me that x minus 3 was negative 3x. No. Now, since this base is alone, it is a base. This is an exponent, which means that all of this stuff has to be an argument or an answer. So I have a logarithm. Its base is 10. Its argument is x minus 3, and it equals y minus 1. Base 10 is understood. We're going to counteract subtraction through addition. And there is my inverse. Done and done. And number 5. A bacteria colony doubles in population every 7 hours. If 20 are present now, using ... If I double, my rate of growth is 100%, which is 1 as a decimal. So I even gave you the right formula. The amount after time passes is the principal of 20 times 1 plus 1, because r is 1, raised to t over 7. And I don't know why we can't add 1 and 1 together, but it's 2. This is 20 times 2 to the t over 7. You look dumb when you leave something that says 1 plus 1. You do. You need to understand that. Everybody's always worried about their appearance in this life. Well, you need to be worried about how you look when you leave stupid things like 1 plus 1. It's 2. Write a 2. Part 2, convert your model into a model that describes the population every hour. So we've got our 20, we've got our 2, and we're going to bring that 1/7 inside. And then, by God, since you're holding a TI-84, you're going to see what 2 to the 1/7 power is. It's 1.1041. So 20 times 1041 to the t. That's supposed to be a 1. That's how you do that. I noticed a lot of kids didn't know how many zeros were in a billion. That would be a million, right? That's a billion. 9 zeros. So 1 billion equals 20, and I told you to use the guy from part 1, times 2 to the t over 7. All right, so let's go to our TI-84, our good old trusty calculator. Y equals 1 billion. We'll do a zoom 6, but it'll be absolutely useless to us. You should have figured that out by now. You do a zoom 6 because you don't know what your previous window settings were based on who grabbed your calculator. And some of you are discovering if you don't get the windows quite right, the calculators freeze up quite often. Wait till the little circle's done. All right, we need to change our Y max here to be something over a billion. So I'm going to do a whole bunch of ones. That looks right, I'm counting. And I'm going to go out 100 hours in the future. I don't think that's enough. Maybe I'll see something. I can see it being drawn, but it really hasn't grown all that much yet in comparison to a trillion. So let's go out 300 hours in the future. And what's funny about exponential growth is it almost looks flat until it's not flat, and then it just shoots straight up. That's how exponential growth works. All right, I've got an intersection, second trace, 5, enter, enter, enter. Takes 179.02797. 179.02797 hours. Now, some of you are probably curious how I convert this into days, hours, and minutes, and so forth. I know that there are 24 hours in a day. So it's 7 days. Now, since I've already counted for that 7, I'm going to take it away. I know there are 60 minutes an hour. Sorry. I've taken away the full days. I'm going to multiply by 24. This is my hours, 11 hours. I'm going to take away what just got accounted for. I'm going to worry about minutes now, 60 minutes an hour, so times by 60. 1 minute. Take away what I have accounted for. Maybe if my calculator will reopen, because I have so much time during my lunch break. And I'm going to take the rest of it and move it into seconds. So times by 60, because there's 60 seconds in a minute, roughly 41 seconds. It's going to be rounded. 7 days, 11 hours, 1 minute, 41 seconds. And that was the quiz you took on Hump Day.